Hello and welcome to another of our YouTube video. Today we would be looking at time series forecasting, and I would go through three different simple time series forecasting methods that we could use to just do some basic time series analysis. I have three examples that we would basically use to do these different methods, but just to give you guys some overview. The first method is what we call naive time series forecasting. It's the basic time series forecasting method. The second one is the moving average and the exponential smoothing time series method, right? And then finally, it's the last one is called the trend analysis, which is basically using simple linear regression to do a time series forecasting. And basically what we do in that one is to just look for the trends, right, that are present in our time series data. And then just remember, when we say time series, we're basically talking about data that is, or observations that are time dependent, right? So any observation that is attached to a time, right? So basically observations that are being collected either per minute or per hour or daily or weekly or monthly or yearly or in whatever time intervals. We call them time series, and would also look at what kind of chart we could use to graph or visualize a time series data. So please stay tuned, get your R Studio software open and ready to do the analysis with us. I think for the TED example, for this one, I got some inspiration from Skechers, right? Which is a footwear company located in Manhattan Beach, California. And it's a real life data. So if you go over to this link, you would actually see the data, and we'll just try to do a simple linear trend analysis with their data and see what their revenue would look like in 2023, right? So would have an opportunity to come down all the way to this example. But let's start with the very first example, which is a naive forecasting, right? So we have some data points there for 7 different months. And you could see they basically range from the lowest one, which is 12, all the way to the highest, which is 24, right? So month one had a very high observation. And then as it went to month two, it reduced by almost half and then increased again by 7 units in month three, dropped again by 8 units in month four, and just you could see that fluctuation there, right? So this is just a very simple question. Do a time series analysis on this using the naive approach, right? Which is like the basic approach. And then we have to compute the MSE, which stands for the mean square error, right? It's a performance metric that we use when doing time series forecasting. And then we're also asked to calculate the what's it called? We're also we're also asked to forecast for month 8, right? Which is not basically here, right? So we're going to try to estimate what month 8 will be. And then for part B, we're asked to use a different method, right? The first method here is called the most recent value. And then here is to basically take an average of all the data and use that to forecast the next month's data. And then basically compare between A and B, which one is better, right? So I'll show you guys how we can answer A, B, and C. So let's get started. And then feel free, you could replicate this to any type of data you have out there, or you can extract data from different websites, right? All right, so let's get started. I'm just gonna put like a header here. Put in basic time series forecasting method. And the very first one, so let's say example 1, we use the naive approach. Okay, so let's just say our time series data, right? So our months, we have 1 to 7. So basically that there, line number 5 just basically tells R that we're looking at monthly data, and it's from the first month all the way to the 7th month, right? And then the values, we have that as this, so it's going to basically put everything in an array. 13, 20, 12, 19, 15. So 24, 13, 20, 12, 19, 20, 21, 15. Yeah, so that's all of our data there. So we want to answer the first question, which is part A, and it's asking us to use the most recent value as forecast, right? So I'm just going to put it here so I remember most recent value as forecast. All right, so the first thing for the most recent value is that we want to exclude the last value. So basically we do not want to include 15, right? So the first code we would write would be for our forecast. So I'm just going to say forecast for part A. So values. So this is basically the length. And then values. Right, so we're excluding the last value, right? And then we have our actual, which would be all the values, and then we would exclude the very first value. So then to get our MSE, we do the mean. So the MSE would be, the MSE, remember, it means the mean squared error, right? So the mean squared error would be the actual, right, subtracted from the forecast, and then you take the square of it. So this would be our MSE. So let's run this. So our MSE is 60.5. That's our MSE. So our mean squared error, right? It's 60.5 when so I could just put the result beside it as. So now let's try to forecast month 8. So here we'll just say till at least 1. This helps us to do that. 8. So we're trying to predict the 8th month, right? Because our data only goes from month 1 to 7, right? So now we want to predict a new value or forecast a new value. So if you run this, so it's telling us that for month 8, we'll be having 15, right? We'll probably have like 15 units or something. So that's what our forecast would be for month 8. So this is basically how we solve part A, right? It's just simple and very straightforward because we're not doing any complex analysis here, right? Now let's do part B. So part B is average all of the data, right? So we're going to average all of the data. And in order for us to do that, we need to use the cumulative function, because we have to take a cumulative average of all of the data, right? Basically the cumulative average of all of this, right? That's what we're doing. So let's say cumulative averages, right? Which would be cum sum, that's the function. And then values Remember, we take the length of the, which is very similar to this, right? We take the, we exclude the last value, right? And then we divide up by 1, which is the length of our data. And then we subtract 1. Because we reduce this by 1. So that's basically here what we're saying is take the cumulative average. So that's basically what this code here means. Take the cumulative average of the data. And then we have, so then we have to write our forecast. Yeah. So forecast B would just be cumulative averages. And then our MSE, no, we need to do the actual, sorry. Actual B would just be very similar to that one. Values 1. So, and then our MSE for part B would just be the mean of actual B minus the forecast B. That's what our take the square. And then MSE. All right, so let's run this. All right, so you can see our cumulative there, right? So remember we started with 24, 13, 20, 12. You know what? Let me just print it out here so we could see it clearly. So cumulative averages, right? So remember the data here starts with 24, 13, 20, 12, 19, 23, and 15, right? That's our data point. So when we say cumulative average, right? Right, the first one, we don't have any data before 24, so it has 24 down. Then for the next one, what it would do is for the next one here is that it's going to do 24 plus 13 divided by 2. That's how you get 18.5, right? So that's our cumulative average. So for the next one to get 19, would be 24 plus 13 plus 20. That's how we get 19. So we keep doing that, right? So that's what our code in line number 17 helps us to basically do, to get the cumulative averages. All right, so now we can see our MSE, right, for part B. Our MSE comes out to be 36.12. So that's how to do the MSE for part B. Now part C says, which method appears to provide the better forecast? So basically what this question is asking us is that between part A and B, which method has the smallest MSE, right? Because we're looking for which one has the smallest error, right? So remember, if you're doing regression, forecasting is like regression, right? If you're doing regression, we're always focused on the model with the smallest error, right? So in this case, if we just take a look at the MSE from A and B, right? A was 60.5 and B was 36.12, right? We could literally see there that B has a small error compared to A. But I need to finish up something. We also need to do the forecast for month 8. And let's see what we get. Right, so forecast month 8 and score B. So till this is going to be, let's just put this note there. And this. All right. So yeah, so we have our forecast for month 8 as 15. Yeah, which is very similar to our previous forecast. So um, 15. No, this is not correct. So this should be, because we're asked to find the mean, so you should just be the mean average of all months. That's, yeah, complete MSC using the average of all the data available as a forecast for the next period. Yeah. So so this should be, yes. Okay, so our forecast should be 18, right? That's what our forecast should be, because we're being asked to use the average of all months as forecast for month 8, right? So yeah, so our answer is 18. Okay, so and then part C is just saying which method is better, right? So I'm just gonna be a little bit fancy, let's see, I'm just gonna say, so better method, I'm going to use the if else function. Then it's MSE. So basically, remember, we're looking for the smallest one, right? So it's MSE less than MSB, right? And if it is, so we have most recent value. Remember, that's what question A was asking us. And then question B was asking us for the average of all data, right? And then I'm just going to ask R to basically list it out for us. So let's see, MSE, let's see, MSE underscore most recent value. And let's have that as our MSEA because that's our most recent value. And then we also want to forecast for month this, right, which was 8, that's most recent. Let's put this at a small letter, just be consistent. So that would be forecast for month 8. Then we also want the same thing, MSC average of all data, and that's our MSB, and then forecast forecast data, and it's going to say average, right? And then AB, then we'll just say the better method should be called the better method. So just something fancy, nothing much, run this. Okay, so it's an unexpected symbol. So let's see, MSE. Oh, I forgot to put my commas. So it was reading everything as one line of code, which is wrong. So now it should work. Boom, I told you. Okay, so basically, remember I told you when you just look at it. So here, our MSP was 36.12, and our forecast here was 15, and then here it was 18, right? So if we just look at MSB versus MSA, right? MSB is basically the best because it has a small error, 36 compared to 60, which is large. So if you run our result, you can see it gives us the most recent value, which is 60, the forecast, which is 15, MS average of all 36, forecast is 18, and basically selecting that the average of all data is the best. So that's basically how we answer example 1. Okay, now let's do example 2. I hope you guys are excited by it. We always get the errors, but I think I've had how many? 2, just 1 error so far. Okay. So we'd always get the error. But I think how you kind of solve the problem or troubleshoot it and get a solution to your error helps you understand what you're actually doing. So that's how I see it. All right, so now let's look at example 2. So example 2 is now looking at on-time shipments. So basically when we get those deliveries on time. So for the Hawkins company, the monthly percentages of all shipments received on time over the past 12 months are, so it gives us all of those numbers of all the shipments that they received on time. So we're being asked to construct a time series plot. Remember, I asked you guys what kind of charts do we use to display the data for time series. So we use a time series plot. It's basically a line chart, but the x-axis has all the date information or the time interval information. So it could be minutes, it could be, let's just say it could be seconds, it could be minutes, it could be hour, it could be daily, it could be weekly, or monthly or yearly, right? So that's what the x-axis would have, and then the y-axis will have all of your observations, which are dependent on the time in your x-axis. So we're going to construct a time series plot and then try to see what type of what type of pattern that time series plot follows, right? Then we'll compare the 3. So here is where we use different smoothing techniques. The first is moving average, and the second is exponential smoothing, right? We generally use this when we're trying to see if we could level out the fluctuations that are going on in our data set, right? That's why we use the smoothing technique. So the first one will be moving average, and then you can see there that it says we should compare it with the exponential smoothing approach, and we're given an alpha of 0.2, and then see which one gives us the best forecast, and we're using the MSE, right? I know here I'm using the MSE, but I would challenge you guys, right? My question to you, or my challenge to you, is for each of these examples, right, on your own, try to solve it using a different forecast accuracy, right? But for example, 2, someone take it as a challenge, try to solve it with MAPE, right? And put your answer in the chat. If possible, put what error code you use. If it's correct, I would like it. If it's not correct, I'm gonna I just put a comment to let you maybe know where you made a mistake and basically just kind of correct you on that. But the MAPE stands for the mean absolute percentage error. So hopefully that gives you a hint on what that forecast accuracy is about. So that's my challenge to my viewers out there. Okay, and then the last question is, what is the forecast for the next month? Basically month 13, because we have 12 months here and we're trying to look at what the forecast is for month 13. So let's see how we can solve example 2, right, which is centered on moving average and exponential smoothing approach. So we're going to be doing two different methods here. So the first thing I would say is install some packages, right? If you don't have these packages, please go ahead and install them, right? DB-YR, I guess, yeah. And then install packages, Zoom, yeah. So please try to install those two packages. I already have them installed, so I'm not going to install them, right? But I would just leave them there for those of you that need to install them. So these two packages basically help us to do the moving averages. That's basically what they help us to do. And they also help us, I think strictly with working with the moving averages, right? And then the library, I put 00. I'm trying to see. So let me. No, I think I have it installed. Yeah. So you could see there helps us with time series, and then DPLYR. Yeah. So basically helps us with the data manipulation. So that's what those two packages help us to do. So I'm just installing them. Okay, so now let's create a data frame and put our data into it. So the first one is just a data frame. And then we have months equals C. So we have to write out 12 months. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then our data, which we can just copy from that from our PowerPoint here. And copy it and put it here. And then we still the add because we don't know that. Right. And this would be our time series plot. So we use the plot function. Then I'm just going to say df. Okay, before I come there, let's just run. So if we run this data frame, so you could see we have our data frame here, df. So if I open this, you could see we have our 12 months and we have data attached to those 12 months, easy and quick. So now we'd say df $month, right? So, and then df $data, which is the data for the shipments received, right? And then we put the type, which is basically trying to use like an O to denote each data point in our time series plot. And then the color, I'm just choosing blue. You could choose whatever color you want. And then the X label, right? I am going to call my X label month. And then my Y label, I'm going to call it shipments received. And then my so the main, which is like a title header, I'm just going to call it let me see, I would just call it monthly percentages of all shipments received. Yeah, So probably that's what I'll call it. Yeah. All right, so let's run it. Bingo. So basically you could see how it looks like here, right? So the circles just represent all the data points, right? And you could see that movement. So so our question here is, what type of pattern exists in the data? So what type of pattern do you think exists in this data? So for me, I believe it's a horizontal pattern, because we can see that up and down fluctuation that is going on in our data. So in terms of the interpretation, right? Did I forget how to spell yeah, interpretation. We could just say the time series plot exhibits horizontal pattern, right? Because of that up and down fluctuations. All right, now the next thing we want to do is to answer part B. Oh, my bad. I did not put part A here, which is time series plot. Okay, and then part B is, let's do the moving average first, right? 3 months, no, let's spell it out. 3 month moving average. All right, so we're basically going to be taking the average of the first 3 months, and then we'll just be going like that, right? The 3-month moving average all through the 12 data points, right? So please take note of that. So we're going to have to manually write the code that would help us do the 3-month moving average. So we would create, so let's create a new column that would be attached to our data. We could call it average shipment, or we could call it let me see, do we want to call it average shipment, or maybe just call it forecast? Average shipment, let's call it average shipment. So, doesn't hurt at all, so let's call it that. So we need the because we're taking so the first 3 rows would be empty, and then we would have df, so our data, we take the first one and then add it with the second data point, then add it with the third data point, and then we are going to divide by 3. Okay, so take the first data point, second data point, by 3. Right, so to make this fast, I am just going to do this. Make it pretty fast. And explain all of that in a minute. So, yeah. Okay, so now we're going to calculate the square, right? So we'll do that only for the months where moving average is available. And that's basically what we do. So, so then we would use a function to basically mutate everything greater than this. So mutate, we want the squared error. So if else is NA, right? So we go with the average shipment, and then NA. We want the data minus average shipment. Basically, what we're just trying to do is to calculate the MSE, right? Okay, so before I continue, I'm going to run line 53 to 69 and basically show you guys what is going on. So when we run that, if I come over here, right? So this is basically that new column that it creates. Remember, here we're asking it to create a new column called average shipment and store it in our data frame. And then this is basically all of the formulas we wanted to use to populate the data. And I would show you how we got how we got each of the data points for all of this, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So we have 12 rows, which basically replicates the 12 rows we have here in the data, right? So for moving average, right, we take the average of the first three, because we're doing 3 months moving average. So we're basically taking the average of the first 3 months would be our forecast for the 4th month, right? So basically, if you do on your calculators, if you do 80 plus 82 plus 84 and you divide by 3, that's how we get 82 as a forecast in month 4, right? Now for month 5, all you just have to do would you now shift by 1, right? So you wouldn't include 80 anymore. So it's now going to be 82 plus 84 plus 83, right? So basically month 2 to 4, and then you divide by 3. That's how we get 83 in month 5. So that's basically what each of this line of code is doing for us, right? So, and then in line 66, okay, so we mutate that. Line 66 is helping us to calculate the MSE, right? So let's see. So compute MSE. So remember, we have to exclude all the initial month with NA, right? We want to exclude all of this stuff because we don't want to include it there. So MSE would be the mean of DF squared error. So we basically exclude, helps us to exclude all of the NAs. So basically what line 66 is doing for us is that it's creating a new, so let's see, we have it here, 4 observations now. So it's going to create a new column called squared error. And what this squared error means is that it's basically going to do 83 minus 82, and it's taking the square. So 83 minus 82 is 1, and the square of 1 is 1, right? 83 minus 83 is 0, and the square of 0 is 0. 84 minus 83, or 84 minus 83.3, let's see, that's 5, is 6 this and square, right? So 84 minus 83.3333 blah 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 is 0.66667, right? And if you take the square of that, it gives you 0.444, right? All of this, right? 85 minus 83, and then you take the square, that's how you get 2.78. So that's basically what line number 66 is doing for us, right? And then line 72 is now basically taking the mean of all of this, right? So basically add all of these numbers up and divide by 9, right? That's what it's doing for us. And then it's also telling us that, hey, on this row, we have some NAs. So you don't want to include it, because if you include the NAs, then that means you're dividing by 12 instead of 9, right? That messes up the whole stuff for you. So if we run that, what? Ding, 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 ding. Okay, so let's see, what did I make? So it's saying unexpected symbol. Oh, I see. It should have a double. Oh, sorry. I made a mistake there. Yeah, this is what it should be. All right, so another error shows that we're doing it correctly. All right, so our MSE should be 1.23, right? That's what our MSE should be. So let's put it here, 1.23. Yep, that's what our MSE should be. So now let's try the exponential smoothing. Okay, so exponential smoothing, and we should use alpha of 0.2. All right, so I hope everyone is having fun up to this moment. So, because I am having fun, especially when I get the errors. All right, it makes me to be serious with what I'm doing. Okay, so alpha is 0.2, right, given in the question. And let's see, so exponential smoothing, rep. We also have to take the length of our data, because we're just working with the data, which is the original values. And then exponentials. Just the first one. Yeah. That's basically going to be our starting point, right? So we're starting with the very first data. And so that's our starting point. So then we're going to write just like a for loop, right? For I in 2, basically we're saying that we're now using I to represent each of our data points, right? Then the length would be, let me spell it correctly. So the length of df data and curly brackets, the exponential. So the alpha, what I'm doing is I'm just writing the equation for exponential smoothing here. Dollar data I minus 1 plus 1 minus alpha. Yeah. So this is just basically us writing the equation for exponential smoothing, right? That's basically what it is. So the alpha coefficient, right? Alpha, or the alpha term, or the alpha constant, or whatever you want to call it, right? So it's the alpha multiplied by the first data point minus 1, right? Plus 1 minus alpha multiplied by the exponential, like the previous exponential smoothing. So that's basically what that line of code is. So then we can calculate our MSE. So this would just be, let's say, MSE for the exponential smooth. Oops. So that one, the equation doesn't change. DF data. So we start from the second row, right? Let's subtract it from exponential. And the second, this, remember to square it. All right, so let's run this. Oh, I didn't run one more thing. So MSE, this, so that I can print out the answer first. All right, so let's run it. Okay, so our exponential smooth is 3.56, right? Ooh, so just looking at it, you could see that our moving average kind of performed way better than the exponential smoothing, right? Because it had the lowest, what's it called? It had the lowest MSE, right? 1.23 is way lower than 3.56. So, because remember, it says we should compare, right? So just to, I'm just gonna be fancy, but let's see, I'm gonna copy this, right? I kind of use that again here, just making it look cool. So do not blame me for wanting to look cool. Let's say for result, I'm just going to say which one was better again. Average of all, yeah. So average of all data. So for this one, right? So here we're just going to say MSE is less than this. So copy this so I don't have to write it again. This would be, just going to copy this here. Put it in here. And then copy exponential smoothing. So this should be, let's see, again, average. We really don't need all of this though. So MSE X natural smoothing, and then I can just copy this and paste it there, right? Then the better method, we call the better method. So that should be good. So we can still have result. All right, so let's just run this. Ooh, I just have to put a small title there and just say compare. All right, so you can see the 3-month moving average is the best, right? Because it has it's the one with the smallest MSE. All right, so now my next challenge to you is to try to use either the 3-month moving average or the exponential smoothing to forecast the next month, right? So basically try to forecast month number 13. So that's my challenge to you. If you get it, or if you feel that you have the correct answer, please put it in the chat. I would put your code and your answer in the chat. I would look at it. If it's correct, I would like it. If it's not correct, I would kind of put a comment and let you know it's not correct and basically show you what the correct method is. All right, but I've showed you guys how you could do A and B. Now I want you to kind of use that information I've given you to see if you could forecast what the next month will be. Now, part C, which is example 3 on linear trend, right? That's the performance footwear revenue from Skechers. So let me see. I'm going to try and open a web tab here so I could show everybody where this data comes from. It's real life data. If you're interested in building a portfolio, you can get data like this and just build some analytical things from it. So this is the micro trends, right? And this website, it shows you the revenue or the profit from different companies, right? So this is Skechers, right? Here, a US company. You know, it has so the annually or quarterly revenue history and growth rate from 2010 to 2023, right? So that's basically like 13 years worth of data, right? You could see the company as of June 30th, the revenue was like 2 billion, right? Which is a 7.75% increase, right? And then revenue for 12 months ending in June 30th was like 7.77 billion, right? Annual revenue in 2022 was 7.44, 2021 was 6 point something, 2020 was 4.6, right? A very, very low revenue in 2020, which we could always attribute to the pandemic and all those blah, blah, blah stuff like that. But we're not really worried about that, right? So this is all data, you know, they've created. So this is also like a time series, but this is just a column chart, right? But then the data that we'll be using for the analysis today is this data here, right? The annual revenue, which is in millions of US dollars. So basically taking all of this data and I put it in an Excel file, right? I would have the link in the description so that you can use the same Excel file to basically build the linear model that I will be working on here, right? So let's try to predict. And so they have from 09 to 2022. So we'll try to predict what their 2023 revenue will be like, right, at the end of the year. Because here you could see what this is from a quarterly perspective. So after June, they had $2 billion, right? Or I don't know, $2 million, sorry, $2 million, not billion, $2 million, right? Quarterly revenue. So let's try to see, we're still waiting to close out the year, right? For 2023. So let's see what that figure will come out to be. So let's go. No, take this out. So we're also going to construct a time series plot, and then we could see what type of pattern exists in that data. We'll develop the linear trend equation, and then we'll use the equation to forecast for period 15, which is 2023, right? So follow me along as we work on this. So I'm just going to put example 3. So we need a couple of functions, just two libraries. So that would be read Excel. I think everybody should have this. And then if you don't have it, please look at my previous post. It will show you how to install read Excel, or I think one of my early posts. Show you how to install read Excel and ggplot2. Okay, so then we have to, I didn't write that correctly. Load the data. Load the data, right? So I think I used df before. Yeah, I've used df before. So maybe now I would just say df1, right? And read Excel, file, choose. So oh, I did not run the libraries. But that's what happened when you don't pay attention. Okay, so Excel. Now it's gonna work. Purchase sales, open. All right, so our data is here. You can see we have the 14 observations from year 1, which is 2009, all the way to year 14, which is 2022. So for when doing linear trend, for time series analysis, basically what you're doing is just simple linear regression, right? We need to introduce one more variable, which is called period. And we use that period to depict the year because you cannot actually put 2009 or 2010 when building a regression model. So we need to use period, right, to basically code each of these years. So 2009 is our starting year, and then we just go all the way to 2022, which is year 14 or period 14, right? And then you can see our revenue in millions of dollars for each of those years. So make sure that whenever you're doing time series analysis, you always want to have the period to kind of use that to depict each year. So the next thing we want to do now is answer the first question, part A, time series plot. Okay, so we're using the ggplot. So, so that helps us with visualizing our data. We use AES, yeah. And then we define what X is, which is period. And then Y is revenue, loss. Then we have the channel line. Plus we have the June point. Then the next one is our X labels. So our X label, you know what, let's call it, let's change this from period to year. Like we want it to be year because we have year in our data. So X label would be year, right? Loss, our Y label will be revenue. Remember, it's in millions of dollars, right? And then our chart title, GG title, would be called time series. Oh, I should put that in capital. Time series of sketches. Yeah, I think I spelled it good. No, I didn't. Sketches revenue. Okay. All right, so that's basically what it's going to look like. So let's run this. Now let me run it from here. All right, so you can see it there. So this interpretation for this is completely different, right? It's not like the previous one that was a horizontal pattern, but this, you can see that trend, you can see that increase, right? As the revenue goes from one year to the other. So this basically has like an increasing pattern. It's not a horizontal pattern like the previous chart that we had. So we could just say increasing pattern or trend. Let's say or trend. All right, so the next thing we want to do is to develop our trend equation, our linear trend equation. So that should be part B. Yeah. So we're just going to copy that, put it there so I don't have to write it again. All right. So we use the regular regression model, LM, or regression function. And then here you have revenue, which is our dependent variable, against period, which is our independent, and then you call the data, which is df1, right? And then you have the summary and the model. So let's run this and let's run it. So you get this, right? So remember, it was revenue against period. And then when we look at the coefficients, we're really interested in the period, which is like our year. We could see that if we assume an alpha of 0.05, our p-value is very small, which shows that it's significant. Our B1 is 434.92 and B0 is 305, right? So, and then also when you look at the multiple R square, right? Because this is what we're using. We're doing simple linear regression, right? So you use the multiple R square. So you can see that this is very close to 1, which is a very, very good model. And then you could see that also our entire model itself is significant because the p-value here is less than an assumed alpha of 0.05. So those are some things you want to look out for. So so let's just say so result linear trend equation. This is basically how you write it for time series analysis. So please just follow along as I try to write it there, right? So this would be 305, or let's just say revenue equal to 305.05 plus 434.92 multiplied by period, right? So that's basically how we write it, right? Or you could say y equal to 305.05 plus 434.92 t, right? So t basically denotes the time, which is the same as period, right? So it's either you write it this way or you can write it this way. So please take note of that. Okay, so we're almost at the finish line. Thank you for staying all the way to this point, right? So let's do part C. So part C is for us to forecast the revenue for period 15, right? Basically 2023, right? Let's forecast what their revenue would be in 2023. All right, so we'll just say forecast period 15, right? And we use the predict function, just like my previous videos. Model, and then you have your new data, which would be put in a data frame, right? And then we call it period equal to 15. And then we just print out the forecast. Forecast period. And then we can put the result beside it as well. Okay, so let's run it. Boom. So they would basically be making in millions. So let's see, 828.802 times. So let's see. I can tell you they'll be making a lot of money. So because 6828, that's a lot of money. Let's see. Yeah, almost they will be making like around maybe 6. So this year is 7 billion, right? Because that's basically what they were bringing in. Yeah. So June they had made $2 billion. So which is yeah, they had made $2 billion. So 2023, just based off our simple analysis, it's telling us that they will be making 6 billion, right? Close to, let's just say they'll probably make another $7 billion in 2023, right? Although this year doesn't look like, it doesn't look really good, the fact that they made $2 billion in June. But let's see, right? Remember, we're seeing them growing here, right? So they might make $2 billion. They might make $2 billion, but sorry, $7 billion, or close to $7 billion. But let's see. Let's see. All right, so that is the 3 different methods that we've used to basically answer the 3 different examples we have here: the naive forecasting, the moving average and exponential smoothing, and then the linear trend analysis. If you have any questions, please leave it in the comment section and I'll take a look at it and respond to you. And please don't forget to like the video and also subscribe to our channel. But thank you so much for staying all the way to the end. We really appreciate it. Thank you.